Okay, in this lecture, we're going to talk about how to describe or how to write increasing and decreasing intervals from a curve. And what I'm going to start with isn't really the main part of the lecture, but I want to describe it a little bit because it's useful, and we'll use it again in a little bit later. So if I have some sort of a curve, and let's say it's a cubic curve, and so that it goes up, it turns around, and what that's going to have is this particular curve is going to have 3 zeros right there. The maximum number of zeros that a curve can have is equal to its degree. That's the maximum number. Now, some of them can be repeating, and so I may not actually see all the zeros. Some of them could be imaginary, but the maximum number will be equal to the degree. And actually, when I count the imaginary and repeated zeros, it will exactly equal the degree. Okay, so then we go to the thing called a turning point. And a turning point is where a curve goes from increasing to decreasing. And every time that happens, it creates what's called a local minimum and a local maximum. So you can see right here, I'm going upward. If I go this direction, I'm going up. Then I hit some peak, and then I start going back down. So this point right here, that would be a turning point, because I'm changing directions, and each turning point is either going to be a minimum or a maximum. In this case, it's a maximum. And then I go down, and at this place right here, I swing back upward. So I'm going downward, then I swing back up. This would also be a turning point, and it would be a minimum, right? So this would be a turning point, and it's a minimum. And what we're going to do is we're going to use those turning points, because you can see that right here I have an increasing as I go toward this turning point, and then I'm going downward. So every turning point will create an increasing and decreasing interval. Right? How many turning points can I have? Well, that would be equal to the degree minus 1. So if I have a cubic, the maximum number of turning points I would have would be 2. 2 turning points. Okay? So now what we want to do is we actually want to describe our increasing and decreasing intervals. So that's really the main part of this little lesson. So I'm going to go ahead and move on to the part where we're describing the intervals. Okay, so let me just draw a curve up here. Not a good one. That'll work. Okay, so what we have here is we have a turning point right there, and let's say that that turning point looks like it is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's at 0, 9. That's one of my turning points. Another turning point would be negative 1, 2, 3. So a negative 3, negative 2. Okay, so this is what I need to define. I need to find out where I'm increasing, and I need to list where I'm decreasing. Okay, so let's think about that. This is how it works. What I'm going to do is I'm always going from left to right in the x. I'm going to be going to increasing x values. And what we're going to decide is where's the y value going down. Where's it decreasing? So as I move from left to right, you can see that in this area would be a decreasing. My y value is dropping, right? So that's a decreasing interval. Then as soon as I hit the bottom, I start going back up. That'd be an increasing interval. Then I hit this top part, and I'm going back down again, decreasing. At the points where I'm at the turning points, I'm not increasing or decreasing, so I'm not going to use those. So how I would specify this is anything that's out here, I'm actually going downhill. So I could say I'm decreasing where x is less than 3. Less than a negative 3. Okay? And I'm also decreasing once I hit to this peak point right here in this area from x going out this way. Once I get to this value of x, as I keep going, I would actually be going down this hill. So the other decreasing would be where x is greater than 0. So there's my decreasing intervals. Now I need to list my increasing interval, and that's going to occur in this area right here. Here's where I was actually going up. And so those x values go between this point and that point. In that little bitty range for x values is where I'm actually going up the hill. And those would be where values of x would be a negative 3 is less than x is less than 0. Okay, so a summary of what we did is we found what were the x values that made the y either be increasing or it made the y value be decreasing. So now we're going to take something that's real similar but a little bit of a different look at it. And now we're going to find the x values that would give me a y value that's greater than 0 or a y value that's less than 0. And I'm going to make this a little simpler. I'm just going to go ahead and draw like a parabola here. Okay, now I don't care where y is increasing or decreasing. I'm concerned about where y is greater than 0. That would be all the values of y that are above the x-axis and the values of y that are below the x-axis. So if I wanted to draw that, these are the values of y that are above the x-axis. And these are the values of y where I go below the x-axis. So these all above the x-axis are my positive y values. Below the y-axis would be where f of x is less than 0. Above the x-axis would be the place where y is greater than 0. So what I need to do is specify those. Okay, so where is y greater than 0? And where is y less than 0? Okay, so let's take a look at that. And I can see that y is greater than 0 for all my x values out here and out here. So what that would be is for where x is less than 1, 2, 3, 4, 5, 6, 7. So y is greater than 0 where x is less than a negative 7. And y is also greater than 0 where x is greater than a negative 1. Y is less than 0 for the parts in between there. That would be this part in here. All those places are where y drops below that. So I could say that between a negative 7 is less than x is less than a negative 1. Those where the y values go below the x. That's the x values that cause y to go below the x-axis. Notice again, I don't ever have any equal to signs because right at the transition point, y is equal to 0 right on the x-axis. So y is not greater than 0, y is not less than 0. So I don't put any equal to signs underneath my inequalities.